Hey everyone, in this video we will start with another graph, another basic one, and it's going to be the linear graph y equals to mx plus c. Alright, so I'll start with a very simple example. So I'll start with just mx, alright, where m is any real number and c is any real number or constants essentially. Alright, so let's start with the very simple y equals to x. Alright, so whenever you're in doubt, draw some points, alright. Equate some points and then we'll draw the graph from there. So we know that at x equals to 1, y is 1, right? Then we have over here is one of the points, right? Of course, label your x's. Okay, now we have x equals to minus 1, y will also be minus 1. Therefore, here's minus 1 for x, here is also minus 1 for y, therefore this will be our other point. We can then take more points if you're uncomfortable because it need not necessarily be a straight line. So let's say we take x equals to 10, or actually in this case let's take x equals to 5, y will also be 5. So in case it will be 1 point down here. Then again we have minus 5 and 5. Basically any value that x takes, it would be the same value for y. And what you notice is that our graph kind of gets a straight line, right? Because at every value of x, y value becomes the same, right? And you realize that they basically get a straight line from here passing through the origin, because at x equals 0, y equals to 0, and that would be the y equals to x graph. All right, so it's a linear graph that is going upwards. Now all the graphs of y equals to mx plus c, whether m is positive or negative, whether c is positive or negative, would be a straight line, regardless of m, regardless of c. Alright, just to give it another example. So now we had y equals to x, right? What if we now have y equals to, let's say, minus x and then plus 1, alright? So I'm going to combine the negative gradient and the constant c together. I'll talk about gradient in the next video. Alright, so again, we take some more points and we use a different ink so it'll be easier. Alright, so let's say we take a green. Okay, so again, we pick some points. So at x equals to 1, y will be minus 1 plus 1, so y equals to 0. At x equals to 2, y would be minus 2 plus 1, so 1 minus 2 is negative 1. Now we take the negative number, or we can take x equals to 0, really it's up to you. So x equals to 0, we can take y equals to 1, alright, so that's that. X equals to minus 1, so be minus minus 1 plus 1. So minus minus 1 is 1, positive 1. So 1 plus 1 equals to 2. Therefore, y equals to 2. So we're going to plot those points on the graph as well. So at x equals to 1, y is 0. So there's an x-intercept here. X equals to 0, y equals to 1. So there's a y-intercept here. Then we have x equals to 2 and y equals to minus 1. So x equals to 2 is somewhere around here. Minus 1, so one graph down, so that's that. X equals to 2, oh wait, we plot that. X equals to minus 1, y equals to 2, so we then have 1 point here. From here, right, we pull our ruler again, and we notice that the line is now going downwards, right, instead of going upwards like y equals to x. But nonetheless, it is still a straight line, alright? So I'm going to position my ruler kind of perfectly because I have these markers, and there we go. Alright, that would be the y equals to minus x plus 1 graph. Alright, now you can give it a shot for y equals to x plus 1 graph or y equals to 2x plus 1 graph. You will notice that the graph will, right, let's say you take y equals to 2x, it will be much more steeper. It will be going up like the y equals to x graph, but much more steeper because of a larger gradient. But I'll leave that to the next video where I talk about gradients of a linear line graph.